evaluate the integral of sine of x over cosine squared of x with the boundaries 0 to pi over 4. Let's start by finding the primitive function of this expression here. We're going to use a method called substitution. So we'll do our substitution on the side here. I'm going to write substitution as well, because it's good practice. On substitution. We're going to make the substitution where we call u equals cos of x, and then the derivative of that is naturally du equals minus sine of x. This is an important thing to remember. I had struggle remembering this when I started doing integrals. And this is that this du is just the derivative of this one. Sometimes when you see people do substitutions, it's like, what's happening here? But it's just the derivative of what you substituted the thing with that becomes the new derivative part of the integration. So if we use the substitution to rewrite this integral, I'm going to use indefinite integral here. Whoop. Oh, well, obviously we get 1 over u squared. That's the same as 1 over cosine of squared, like this here. And then we're going to get in the derivative here, minus sine of x. But we got the positive sign here. That means we are going to write this as times the negative du. Aha. Sneaky, huh? Because when we rewrite this later on in further steps below, we can just focus on simplifying this now. So for the first step, we will say that this is minus 1 over u squared. We can also move a constant outside, and here we have a constant that's minus 1. This is minus the whole integral. And then we just get 1 u squared and du. Right? And to make this even easier to continue with, shoop shoop, fast equal sign I can fit on the edge. Quite small space here. We continue here. We can do one further simplification and just write this as u power of minus 2. That's the same thing as the step before. Why did we do all this? Why did we do the substitution? Well, because this is kind of hard to just find the primitive of. So we did the substitution, we did the rewriting thing here until we got this. And this here is very easy to find the primitive function of. Because the general formula here is if you got something like x to the power of n, then its primitive function will be 1 over 1 plus 1 times x to the power of n plus 1. Since you can't see that, I'm going to do the magic of my thing here and move it down. And this is simply just the derivation rule backwards. Because if you derive this, you get that thing. I'm just gonna write the derivation rule to make it more clear. So x to the power of n. If you derive that, then you will get n x to the power of n minus 1. As you can see, this is basically, this here is basically this backwards, and you add this fraction here to remove that n to just get the x that you wanted. So when we find the primitive function of this here, we can now say that the primitive function of this indefinite integral is minus 1 over n, so minus 2, right? This here. plus 1 times u to the power of minus 2 plus 1, which is just equal to 1 over u. As you can see, this turns into minus 1 times minus times minus 1 equals 1, and times u to the power of minus 1 turns into this. And this is luckily very easy now to just put our substitution back into. So if we go up here, u is equal to cos of x, and then you get cosine of x in the denominator there. This is the time when we go back to the integral we were dealing with for the evaluation. So that was 0 to pi over 4. Then we get back here, 0 to pi over 4 of sine of x over cos square of x. And it turns out that this is the primitive function of this. So the value of this when we evaluate will turn out to be 1 over cosine of pi over 4 minus 1 over cosine of 0. And these are standard trigonometrical values. They're very good to know by hand because pi over 4 is the same thing as 45 degrees. That turns this into 1 over 1 over square root of 2. So the trigonometric value of cosine of pi over 4 is 1 over square root of 2. Minus this other expression here will be 1 over cosine of 0 is equal to 1. So the evaluation turns out to give us the following value, which is root of 2 minus 1, which is approximately 0.414. If you want to learn this correctly, see the example here of how to do the substitution, and make sure you do some practice on other problems that's like this, but isn't this. So you get some variation in your practice on the substitution. Best of luck in your studies, and if you have any questions on math problems you want me to solve, please tell me. I'll gladly do some requests. See you in the next video. Bye bye.